Okay, so we are going to be working on this lesson 9-1 after your test today. It's got several different things going on, so you can anticipate at least 2 videos from me, plus I found a third video on YouTube that I want you to watch. I started to just make you work this example and follow this example and then do these right here by yourself. But there was this one little part right here that I was afraid you wouldn't understand. So I decided to go ahead and make a video. The first thing I want to point out is make sure you understand that the particular type of problem that we're working is a particular type. It is where your B term is 0. Notice that here's your standard form quadratic. It's ax squared plus bx plus c. Well, in all of the problems that we're going to work first, there is no b term. We have a squared term, we have a constant, but we do not have that term with just the x. Those are a particular kind of problem, and they can be solved differently than any other problem. One of the things that I hope you remember doing on the test just today is that when we have a problem like this, we check to see if this could be the difference of 2 squares, and we can solve it by factoring. But there's only a very, very small number of these quadratics with no b term that actually have the difference of 2 squares. So we have to be able to solve them if it's not a perfect square. So what happens if these are not a perfect squares? Well, this is what they're going to do. They're going to say, okay, just get the squared term by itself. So we have to undo everything that's happening to it. They added 23 to both sides, divided both sides by 5, and now they have got to get the x squared term by itself. So how do we undo squaring something? We take the square root of both sides. So that's what they've done right here. They take the square root of x squared, that gives you x. They take the square root of this right here, notice the plus or minus. That's because when you square 2 numbers, you can square 2 positive numbers and end up with a positive number. You can also multiply 2 negative numbers together and get a positive number. So this is reminding us, so is this over here, that when you take the square root of a number, in the process of solving, you have to be sure you include both the positive and negative possibilities. But what the heck are they doing right here? That's what I want to talk to you about. So this thing, I'm going to jump over here and use this. So the thing that they're doing right here is a process called they're called rationalizing. Rationalizing the denominator. Now, knowing these words is not helpful if you don't understand what they mean. Rationalizing means that we're taking a number that's irrational. Okay, this number right here is irrational. Why? Because if we go to the calculator and we type in the square root of 5, let me go over here and you type in the square root of 5. It gives us it gives us some decimal values over here. It looks like it's exactly 2.23607, but it's not. It's a whole bunch of decimals beyond that. So these decimals, whenever you get a number that has non-repeating, non-terminating decimals, that kind of number is called an irrational number. So when we rationalize the denominator, what they're telling us to do, or what they're saying is that we have a number in the denominator right here that's irrational, and they want it to be rational. Here's why. I know you probably don't care, but I can't help it. I got to explain to you why. So think back into 3rd grade when you were saying, I don't know, let's say 25 divided by 2. Okay, you take 2 will go into 2 one time 2 is 2. We subtract, we bring down the 5. We say 2 will go into 5 2 times 2 is 4. We have a remainder of 1, and we wrote that as 1/2. So 25 divided by 2 is 12.5. Okay, well, what happens if we said 25 divided by 0.2? Do you remember what you had to do then? In case you don't, you have to move that decimal over one place. So you had to take this decimal and move it over one place. So there's your new decimal value. We had to fill in that open hole, and that became 250 divided by 2. And 2 will go into 2 one time Same thing right here. Bring the 5 down. 2 going to 2 4 times, 1 left over, bring the 0 down, and we ended up with 2 into 250 is 125. So what happens if it was 0.22 or 0.25 or 0.2 anything? You'd have to move the decimal 2 times, and you'd end up like that. Well, what happens if we try to divide by the square root of 2? Well, how many decimals does that have? The calculator may not show you, but if you go to this place on, you can Google, let's see, Wolfram Alpha. This is a super cool site. And when you go to Wolfram Alpha, it'll let you do some mathematics on here. I want to do square root. You can't type in the square root symbol, but they'll let you do square root of 2. And you press enter. Look, do you see this? The square root of 2. There's all of those decimals. So if I'm trying to divide something by the square root of 2, how many times am I going to have to move that decimal place over in order to be able to divide by a whole number? I can't, because these decimals go on forever. So what's happening right here, if I'm trying to divide this number over here, where was my number? If I'm trying to divide this number, I'm trying to go back here. If I'm trying to divide this right here, this 23 by the square root of 5, I would have to move that decimal infinite many times before I could do that division. So that's why they will not let me divide by an irrational number. So the process is called rationalizing the denominator. We've got to take the denominator and do whatever we can to make it be a rational number. The only way to make an irrational number a rational number is to square it. Squaring it means to multiply it times itself. So we have to multiply the square root of 5 times another square root of 5 in order to make it become 5. Well, remember, I can't change the value of this fraction by multiplying it just by the square root of 5 on bottom. So the only thing I can do to a fraction is multiply it by the value of 1, because multiplying by 1 does not change its value. So I take this number right here, multiply it by 1 in its Halloween costume, disguised as the square root of 5 over the square root of 5. That's a value of 1. And then I multiply top and top, bottom times bottom. What do I have now? The square root of 115 divided by 5. This is what we call a rational denominator. So that's what this step right here is. And yes, you're going to have to do that on every single one of these, probably, unless it divides evenly. But if it doesn't, then that's okay. You've got the skills to do it. I'm probably going to run out of time, so I'm going to stop this video before I work another example with you, but I am going to, so that's going to be my next video, is working one of these problems with you. If you think you could do it, a good idea would be for you to go ahead and try any of these before you watch the video, that way you can just kind of watch along and make sure that you did it right. Okay, good luck.